Hi, my name is Parker Harstead, and I'm going to be doing a presentation on algae biodiesel production. So first off, what is biodiesel? Biodiesel is a renewable, clean burning diesel replacement usable in existing diesel engines. It's comprised of monoalkyl esters from long fatty chain acids derived from vegetable oils or animal fats. And what we do is we take those animal fats and we turn them into glycerin and biodiesel through a process called transesterification. So you'll take a triglyceride right here, put it through a catalyst, which is usually sodium hydroxide and methanol, and then you will produce glycerol here and methyl esters, which is going to be your basis for biodiesel. Next up is, what are microalgae? So microalgae are photosynthetic single-celled organisms. They're also called phytoplankton. They're both eukaryotic and prokaryotic types, but we focus on eukaryotes when producing biodiesel. They're also the main source of atmospheric oxygen in the world. They produce approximately 70 to 80% of the world's oxygen. So the next step is how to produce biodiesel from algae. Algae use photosynthesis to convert carbon dioxide and water into nutrient-rich biomass. That's basically all photosynthetic organisms, right? Namely, they produce lipids. These are used in the transesterification process in order to produce biodiesel. Important lipids to note are triglycerides, diglycerides, and monoglycerides. In scholarly articles, they're called tags, DAGs, and MAGs. So how to make microalgae storage lipids? Algae doesn't produce large quantities of tags on their own unless they're under environmental strain. So in order to put them under environmental strain, what is done is called nitrogen deprivation. So when you have algae that is nitrogen deprived, it will want to proliferate way less, which is basically dividing and creating more algae. It'll proliferate way less because it thinks it's gonna die, basically, and it'll start storing tags right here, which are the lipid droplets, basically as long-term energy storage in case they can't find any more sunlight or any other nutrients in order to produce ATP currently. So how that's done is the same way that we've actually learned in class. It goes, we get sunlight, we get CO2 that go into the Calvin cycle to produce pyruvate, then acetyl-CoA, malonyl CoA, malonyl ACP, and then it goes into fatty acid transfer. So we get free fatty acids, and then it goes all the way down here to our triglycerides, and these are the droplets of triglycerides. So the pros of biodiesel production. A large one is that it's a direct alternative to fossil fuels. It can be currently used in infrastructure. So all current biodiesel engines can use, or all current diesel engines can use biodiesel directly without any sort of implementation or anything else that can directly put biodiesel into a diesel engine, and it can run off of biodiesel. Another great thing about it is that oxygen and glycerin are byproducts, which are both extremely useful, right? I mean, we use oxygen to breathe, and glycerin is used in many, many products. It also has extreme carbon emission reductions in compared to normal diesel engines or normal diesel combustion, which comes up to 74%. You can see on this graph, it's a negative 70-ish% for your hydrocarbons productions, which is a large portion of emissions and basically all the bad stuff that's coming out of your tailpipe. Another thing is carbon sequestration. So we have a lot of CO2 in the air, of course, and algae will sequester it as their own building blocks, and they'll use it to produce more algae. So we will have less CO2 in the air, more oxygen in the air, and you can use it for fuel as well as using algae for food products. So the cons of biodiesel production, number one, it's very expensive right now. A 2009 study said that it was about $33 per gallon to produce biodiesel, but that was 11 years ago, and I know that they've gone quite a lot further in the production and scaling of biodiesel. So I know it's decreased, but I'm not sure. I can't find a source on how much it's decreased. Another one is scaling to industrial production is really difficult due to hard to manage growth. So biodiesel likes to reproduce, and it's hard to keep it reproducing at a certain speed that's manageable. Another one is that it's 8% less energy dense than crude oil diesel, which doesn't seem like a whole lot, but it's enough to put into a presentation and say that it's a con, you know? As you can see in this graph, this is actually really useful. I suggest pausing the video to see this graph a little further. Biodiesel is right here, low sulfur diesel is right here, so you can see that biodiesel is 103% the energy of a normal gallon of gasoline, but only 93% the energy of a gallon of diesel. And then it has a wonderful amount more of information on ethanol, methanol, hydrogen, etc. So is algae biodiesel worth it? Ultimately, I think that it's a wonderful thing, and I think that it's definitely worth looking into and possibly investing in, because right now, if the world were to switch from fossil fuels tomorrow, the only current option that we could put into our motor vehicles would be biodiesel. It's the only thing we have infrastructure for. It's the only thing that we don't have to make huge modifications to engines in order to run. Another thing is it's not a cure-all. Biodiesel isn't the most useful form of energy transfer. It's wonderful because we have current infrastructure that allows easy use for it, but there's a lot of other options and a lot of more green options that still don't produce as much emission and things that I think would be a little bit of a better option for long-term effects. Another thing, though, is that algae carbon sequestration is enormous, and it's a wonderful thing, and I think that it's definitely worth looking into a lot more. And I think that's why it's an important contender in the replacement for fossil fuels. There's my bibliography. Thanks.